All right, so this lesson is a review from Algebra 1 on laws of exponents. And so the first rule is if you have the base written twice, you're just going to add the exponents. And so, for example, I have the base of 3 written twice, and so I would add the exponents 4 plus 2 to get 3 to the 6. A common mistake is multiplying the base 3 times 3 to get 9, but you don't want to do that because these are bases of 3, not just numbers. And so if you were to expand this out, the first expression would be 4 copies of 3 being multiplied together, and then the second expression would be 2 more copies, and so this ends up being 3 to the 6th power, not like 9 to the 6th power. And then here, the -4 and 5, those are coefficients. And so those aren't bases of an exponent, so you're just going to multiply those as you usually would to get -20, but then you would add the exponents to get 8. And so always multiply coefficients and then add exponents. And so it's similar for division, but this time instead of gaining copies, we're losing copies with division. And so here you would subtract your exponents. And so if you were to expand this out, I would have 6 copies of 9 on top, and then 4 copies on bottom. And so 4 of the copies would cancel to 1, leaving me with just 2 copies on top. And so this would equal 81. And so the rule of subtraction says you would subtract the bottom exponent from the top. And so here we could expand it out, but in future lessons, these exponents are going to be fractions. And so even if your exponents are fractions, you would still do that rule of subtraction. And so here, the 12 and the 3, those are coefficients. And so you're going to divide those as usual, not subtract, but then you subtract the exponents. So divide the coefficients and then subtract the exponents. Okay, and so that immediately brings up another rule for the negative exponents, because sometimes when you subtract exponents, you end up with a negative. And so if that's the case, you can think of it as it's on the wrong side of the fraction. And so if you have a negative exponent in the bottom of a fraction, you would move it to the top. And if it's in the numerator, technically this would be considered the numerator, you would move it to the denominator. And so for this one, we could expand it out. You would have 4 copies on top divided by 6 copies. And so 4 would cancel, leaving me with 2 left in the bottom and nothing left on top. And so you would put 1 on top. And so this would end up being 1 over 9 squared, or 1 over 81. Using your rule of subtraction, you would have 9 to the 4 minus 6, which gives us an exponent of -2, which means it should be in the bottom of the fraction. And so anytime you see a negative exponent, think that it's on the wrong side of the fraction. And so once you move it to the correct side, you're going to make it positive. And so for this example, we would still divide the 12 and the 3 and get 4. And then we subtract the bottom exponent from the top. We would get 4m -3. And so when you rewrite this, be careful. Coefficients don't get to move. Even if they're negative, they stay where they're at. Only negative exponents move. So that 4 would still stay on top. Only the m would move with the exponent and become positive. The next rule says if you have 2 exponents on one base, this is when you get to multiply exponents. So this often gets mistaken for our first rule. And so an example I like to put is if you have the base written twice, That's when, if you think about expanding it, I would have 2 copies and 3 copies for a total of 5 copies. If I don't have the base written twice, this is when you would actually have a squared cubed, which means 3 copies of a squared, which would end up being a to the 6th. And so if you have the base written twice, it kind of leaves you room to put a plus sign between the exponent. If you don't have the base, the exponents end up being right next to each other, and so that can kind of be a visual way to see that you need to multiply them. And then if you had a fraction bar between them, let's use 3 and 2, that's when you would subtract them. And so for these next examples, I have a 3 and a 2. Those need to be multiplied, so this would end up being 2 to the 6th. Here the 4 and negative 2 would multiply to give me y to the negative 8. Negative 8 means it should be on the bottom with a positive 8. Now, if you have a product or a quotient inside parentheses, this is the only time you get to distribute the exponent. And so you would distribute it to the top and the bottom. And so just be very careful. If it was x plus y, for example, if it was squared, you would not distribute to each term. If you have plus signs or minus signs, do not distribute your exponent. You would have to FOIL that. Okay, so for this term, we have a 3 and a k being multiplied, so each of those would get our exponent of 4. And some people forget to distribute the 4 to the coefficient. Even the coefficients would get the exponent. And another common mistake is don't multiply this 3 by the 4. That 3 is the base, 4 is the exponent. And so that's actually 81, not 12. And so never multiply a big number by a little number. You'll hear me say that a lot. Don't multiply a big number by a little number. Right? And so for this next example, every term would get the 2, the negative 2, the u, and the v. And so we would have negative 2 with an exponent of 2. U already had an exponent, so those exponent ends up getting multiplied. And same with v. And so this would simplify to positive 4 u, oh, I don't know why I was thinking ahead. That should be a 2. U to the 8, v to the 6 would be your final answer. And then here, 5 would get the exponent of 3, 4 would get the exponent of 3. So 125 over 64. Here the 8 would get the 2. X already had an exponent, so multiply. 3 would get the 2, and y already had an exponent, so now it would become an 8. And so this would become 64x to the negative 10th, 9y to the 8th, and then for your final answer, make sure to take care of this negative exponent. Everything else stays where it is, except the x to the 10th should be on bottom with the y. And usually we write our variables in alphabetical order. And then lastly, anything raised to a 0 power will be 1. So negative 12 raised to the 0 power is 1. This entire ugly expression raised to the 0 power will be 1. And so as we practice simplifying these, you know an exponential expression is in simplified form when there are no parentheses or negative exponents. And all fractions are simplified or reduced. And so I want to add a couple things is only one fraction bar. So for example, if you end up with a fraction like 2/3, you wouldn't want to put that on top of a fraction. So let's say I had some other variables down here. This would not be simplified because I have a fraction bar here and here. So don't do that. And then each variable written once. And so here I have m written in 2 places. That is not fully simplified. All right, so looking at our first example, you would multiply the coefficients. So 8 times 5 would be 40, and then add the exponents. And so you would get g to the 8th. And so some distractors would have g to the 15th, or have the 8 and 5 being added. So you really need to know when to add and when to multiply. And so your final answer here would be 40g to the 8th. This next one, we would simplify the coefficients by dividing them. And so we have 4 divided by 6. That would simplify to 2 over 3. And then we would subtract these exponents to get q to the 5th. And so you could also write this as 2/3 q to the 5th, but this is going to be the better way to write it, especially if we have multiple terms that we would need to put on top or bottom of the fraction. So the 2, q, and 5 are on top, the 3 is on bottom. For this next one, each term would get the exponent of 3, and so we would have 3 cubed, x cubed, y cubed, and be careful with that 3 cubed is 27. 9 is a common answer. Don't choose that. And so our final answer would be 27x cubed, y cubed. This next one, be careful, only the 15t is being raised to the 0 power, so that part becomes 1, but anything outside the parentheses would still be there. And so this answer is -1. Now we're going to start getting to examples where multiple rules apply, and usually like the order you go about this doesn't matter, but a good rule of thumb is to get rid of parentheses first. And so this first set of parentheses is telling me to distribute 2 to the 3 terms inside the parentheses. So we would have 2 squared, a squared, b already had an exponent, so that's going to become 8. This second set of parentheses didn't have a purpose. There's nothing to distribute. So you can copy it down without the parentheses. And then something I like to do is put a multiplication sign between each term, just so I know they don't have to stay in this order. You can rearrange the terms, separate the terms. And so when we rewrite this, we would have 4 for our leading coefficient, and then a squared times a to the 5th would end up being a to the 7th. B to the 8th times b squared, we would add those and get b to the 10th. And so our final simplified answer would have a 4a to the 7th and b to the 10th. For this one, like I mentioned above, if you have a fraction, it's going to be better to write this as one fraction. And so since z squared would technically be on top of a fraction, it's not in a denominator, we're going to put that above the 2. And so when you see a -1 power, that means reciprocal. And so a -1 power reciprocal, we talked about how that means move the terms. And so we really just need to flip what's inside those parentheses. So 2 would be on top, z squared would be on bottom, and then that would be a +1. And writing that +1 is very unnecessary, but if this were, say, a -2, we would have a +2 to distribute or a 3 to distribute. And so here it's not necessary. You don't need to distribute a 1 as an exponent. And so our final answer is 2 over z squared. Okay, here we have an n to the negative 5 on bottom, and so remember, only the negative exponent term gets to move. The 2 is going to stay. That 2 is not attached to the n, it doesn't go with the n. And so n to the 5th would be written on top, and then we would have 2 written on bottom. And you don't write the 1 if there's another term next to it. And so n to the 5th over 2 would be our final simplified answer. Here we would divide our coefficients first, and so negative 12 over 8 simplifies to negative 3 over 2. And then I'm going to go ahead and use the rule of subtraction. You could probably envision that we're going to have 5 copies of q on bottom, since there's 7 on bottom, 2 on top. But when we start working with fractions, that's not going to be readily obvious to you. And so I'm going to go ahead and just know that I'm subtracting the 7 from the 2. Even if those were fractions, that's where you would write the q on top, and then top exponent minus the bottom, and then same with the r. And so this would simplify to negative 3q to the negative 5th, r to the 1st over 2. And so now the last step is just to move the q to the negative 5 to the bottom. Everything else stays, including that negative 3. That negative 3 is a coefficient, not a exponent. And so the r would stay on top, and then the 2 would be on bottom with the q to the 5th power. And so your final simplified answer would be negative 3r over 2q to the 5th. Here we have 3 sets of parentheses, but none of them are serving any kind of purpose other than representing multiplication, and there's nothing to distribute, so you can write this entire expression without them. And then, like I did before, you could put multiplication dots between each of these terms, just to remind you that you can move them around, rearrange them. And so our coefficients here are 2 and 3. We would multiply those to get 6. And then we would have u to the negative 2 times u to the 3rd. So remember, we add those exponents. We only have one v term. And then the w to the negative 2 would need to be on bottom as a positive 2. And so for our final answer, we would end up with u to the 1st power, v squared, and w squared. And don't write a 1st power. And so 6u v squared over w squared would be our final answer. On D, there's several first steps you could take, so the order that you go about this doesn't matter. So whichever way makes sense to you, as you check your answers, focus on seeing if your answer matches the answer key, and then if it doesn't, go back and look at the work, because there's many different steps you can go through. The order doesn't usually matter. And so you could distribute this negative 2 exponent to every term. I don't usually like to distribute a negative exponent to a number. And so a first step I would take is to go ahead and move that entire set of parentheses to the bottom, and then make that a positive exponent of 2. And so when you move it to the bottom, there's nothing left on top, so you need 1 as a placeholder. And then don't change anything inside. Don't change the negative 3 on the y. We've only changed this exponent so far. And so from here, this is when I would distribute the exponent of 2 to each term. And so as I simplify this, I would have a 4, and then x6, and then y to the negative 6 should be written on top because it has a negative exponent. And so then now that we have that y there, we don't need the 1. And so y to the 6 would be on top, and 4x to the 6 would be on bottom. Okay, and so for this next one, the only thing really to do is distribute the 3. And so when you distribute a 3 to a negative base, just be careful and put it in parentheses. and then we would have g to the 12th, h to the 6th. And then negative 2 cubed stays negative. It's negative 8, g to the 12th, h to the 6th. Negative numbers only become positive if you have an even exponent. And so our final answer, that negative 8 g to the 12th over h6. And so notice you have a negative 8 here. That's a coefficient. You don't move negative coefficients. You would never rewrite your answer of negative 8 as a positive 1/8. And so don't start doing that now. Only negative exponents move. Okay, this last one, there's several different steps you could take once again. And so the first step I'm going to take is I don't like this negative exponent. And so I'm going to do that reciprocal trick. Make the 2 positive and flip your fraction. Don't change any signs. Just flip the fraction and write everything as is. And then from here, you could distribute the exponent of 2 to each term, but I think it would be easier to go ahead and simplify, in this case, simplify what's inside the parentheses. We know 8 over negative 4 is just negative 2. And then a6 over a1 would leave us with a to the 5th. b4 over b5, 4 minus 5 would give us a negative 1 exponent. And then c2, we would subtract the 0, which we know c to the 0 is 1, but also that would just leave us with a c squared. And all of this is still being squared. And so here you could take care of the negative exponent. I typically wait till the end because sometimes the negative exponents resolve themselves throughout the process. And so my next step is to distribute the square to each term. And so that would give me negative 2 squared, a to the 10th, b to the negative 2nd power, and then c to the 4th. And so for my final answer, I would have 4a to the 10th, and this is when I would add the fraction bar, put b squared on bottom, and then c4 on top. And so your final simplified answer would have a 4a to the 10th, c to the 4th on top, all over a b squared.